Hello everyone, this is the lecture for section 1.4 for our Math 210S portion of the course, composition of functions. So in math, sometimes we need to combine some functions to make new ones, right? That we've seen that certain functions mean something else, but then maybe the output of one function might be the input of another, right? And sometimes we don't want to mess with just messing around with two functions, right? We want to combine them to make just the one function that explains it all, right? That's what composition of functions is, okay? So that's what this section is going to deal with. For this section, okay, that's exactly how actually we define the composition of functions. It's the first functions, right? Output is a brand new input into a second function, okay? This is the notation that we use for said composition, okay? Some of you guys might remember from high school, we might have called it fog. There is a little circle there, you are right, okay? And whenever you see that, that means that we're going to be composing two functions, or that means we're going to grab one of the functions and put it inside of the other. And the order here sort of does matter. So you guys see how G is the second one. This is the appropriate notation. So that means that G goes inside of F, okay? So for example, right, I've got two functions here, this one and this one, okay? I'm going to compose them. I'm going to do this, right? And if, just to get our notation right, this is going to be F compose G of my function X, okay? So what this is telling me to do is I'm going to grab G, all of this, all of that, and I'm going to put it inside of F, okay? And that's what I'm going to do here. Let me go ahead. I'm going to do it all the way out, okay? So then this is going to be F of G, so this means I'm going to put X plus 2 everywhere I see X in F of X, right? So this is going to be X plus 2, whoa, let me make that a nicer 2, huh? 2 quantity squared. Okay, and if I expand this out, this is going to be X squared plus 4X plus 4. Done. Okay, so this is just a combination of the F and G in particular in this way. Okay. Now, if I want to do it the other way, so on the right-hand side here, right, this is considered G composed F of X. Okay, so what this is saying is I'm going to grab F and stick it into G. Okay, so then this is going to be the same thing as G of X squared, since F of X is X squared, right? And now I'm going to stick all of this, right, into G. Okay, so when that happens, right, it's going to be X squared plus 2. There is no simplification needed at this point. That's it. We are done. Okay, now make sure that you get the order right. Okay, thankfully it goes in the order that you see it from left to right. Okay, try to look at which one goes first, which one goes second, okay? Or which one goes into which. That tends to help out when you have to actually write these out, okay? Okay, moving on. I have another example here, right? So now here's the thing that I was mentioning, right? That suppose we had F of X, right? And an H of X, okay? Give me this, right? And then use it to find this. Okay, so originally what we would have to do, right? So let's go back over here. This is the same thing as saying F of H of 1. Okay, and this is perfectly fine. If you want to find H first, H of 1, and then grab that output and stick it into F, right? You'll get the same answer. No problem, no biggie, right? But sometimes, right, we want to completely reduce it and just avoid the hassle of messing with two functions. We just want to mess with one. Okay, so what I'm going to do first, right, is, I'm going to go ahead and look at this notation. This is going to be f of h of x, right? I'm going to grab all of h and put it into f. Okay? So that is what I'm going to do. I'm going to actually go ahead and go over here to do it. So let's do f of h of x, right? That's going to be f of 3x plus 2, right? Because h of x is the 3x plus 2, right? Okay, so here we go. 3x plus 2 squared minus 3x plus 2. Now, this is a big point where people make the mistake. It's minus all of h of x. Okay, so make sure you use your parentheses appropriately, right? Okay, all right, here we go. If I grab this thing, I'm going to highlight it in blue, and I expand it out, okay? 9x squared plus 6x plus 6x plus 4, okay? Minus, now I got to distribute that negative in, right? Minus 3x minus 2. Okay, I get to combine this a little bit. The 9x squared, that gets to live on. So then the 6 plus 6, that's going to be 12x minus 3, that's going to be 9x, right? And then you have a minus 4, or sorry, a plus 4 and a minus 2. So it's going to be plus 2. Done. So this right here is what we will consider f of h of x, or f compose h of x, right? Okay, so that takes care of this. Bam, right? But we have to do this now, right? What's a f of h of 1? Well, we have the function itself. We have this being our composition, right? So what the tail end thing is this thing. What this thing is us plugging in 1 into our composition function. And then that's it. Okay, so then that means I get to do this. I get to do f of h of 1 is equal to 9, 1 squared plus 9 times 1 plus 2. That's going to be 9 plus 9 plus 2. So 9 plus 9 is 18, 19, 20. And we are done. Boom. Okay. Cool. What comes up next is quick checks. I've got a couple more values here that I want you guys to find. Okay. And after that is lecture questions. This is actually a pretty short section. Okay. If there's any questions on the stuff that we just covered, ask me during my office hours, come down to the tutoring center, or ask me during my quick check time. All right. Sound good? All right. Happy studying.